Good day and welcome once again to those sessions, and today we are going to be talking about functions. Functions at grade 12 level, grade 11 level, you will find them in paper 1. This is a paper 1 topic. So at grade 12 level here we have these functions that are examinable. So the functions that we're going to take a look at are parabola functions, which is quadratic. We're also going to take a look at linear functions, exponential functions, hyperbolic, and logarithmic functions. But we're going to do this in different steps. So the first type of a function that we need to take a look at and understand some characteristics that can help us to answer questions is the first one, which is the parabolic function. So let us come to understand what exactly is parabolic function. So the parabola is a function which is also called a quadratic. These are also quadratic functions. So for quadratic functions, they do have a model. The model for quadratic functions is such that f of x will be made equals to ax squared plus bx plus c. This is the model parabola. This is the model quadratic function, and a in this case is a very important exponent. Is a very important value because it helps us to understand the nature of this. So the first thing that I want us to go through is to just understand some properties. We shall start with a property which is about the shape, just the shape of this kind of functions. So first and foremost, the shape that I want us to look at in this case is to understand the behavior of A. Like I said, A in this case is very important. If A is positive, then we have a shape where we say the graph will be a smile. In another language, we can say the graph is a smile because A is positive. It will just have a shape that looks like this, whereby it's facing upwards. But on the other side, if we have the same A being negative, if A is negative, so we are saying the graph is going to be a sad, which will look like this. So when A is negative, your graph is a sad. Your graph is a sad in this way. But if A is positive, then your graph will look exactly like this. So that's what basically the shape of a parabola, of a quadratic function, it is guided by these two, value of A. So A in this case, we are trying to say that A can never be made to be equals to 0. If A is equal to 0, then it ceases to be a quadratic function. A can never be 0. It can be negative or it can be positive in this way. So this is about the shape. Now let's move on to some other properties. Let us understand the next property, which is not the shape. This time around, let us understand a property which we shall just call a y-intercept. How do you find y-intercept of a parabolic function? Y-intercept is found at a point when you make x to be equal to 0 in this function. So we're saying here that if x becomes 0, then you can find y-intercept, because y-intercept, you are crossing at a point. Let's have an example here. If this is the graph that we have, we are saying at this point, the value of y here is such that x, the x value here is 0, so y can be found. Hence, that's why we just have the general rule of finding y-intercept, just making x to be equal to 0, and then you solve. But how do you solve? Literally, if your parabola is of this form, and it's a trinomial, which means when x becomes 0, it means your value of y becomes the value of c. So therefore, at this point, we are saying at that point, you have 0 is to c. This is the coordinate at this point. 0 for x, c for y. Your y here is c. Just like that. Which means if this was a function whereby, for example, we have f of x being given as equals to 3x squared plus 2x minus 7. That makes this y-intercept, when all these become 0, it means your value is going to be 0 is to negative 7. Just like that. So basically, y-intercept, very easy. Make x 0 and you solve. So if you have this, like I say, the value at the end of the trinomial becomes the y-intercept or the y value of the y-intercept of the curve. So from y-intercept, let's move on to the next property, which is how do we then determine what are called x-intercepts. Let us determine x-intercepts. So to get x-intercepts on our parabola, let's have space here, enough space. So let's talk about how do we determine x-intercept. X-intercept, the convention, just like how we find y-intercept, you are making y to be equal to 0. When you make y to be equal to 0 in this case, let's have an example. So if we are given y being equals to x squared minus 3x minus 10. Let's have this example here. How do we find x-intercepts of this? So for parabolas, when you want to find x-intercepts, step number 1, make y is equal to 0, x squared minus 3x minus 10. So y has become 0. We now need to solve for x. But get it right, there are different methods in which we can solve for x. The first method here, you can use what is called quadratic formula. Quadratic formula is known as x is equal to negative b plus or minus b squared minus 4ac, everything over 2a. You can use this formula to find x-intercept here. But if it is of this format whereby it's possible to use some other methods for factorization, because you need to factorize this. Some other methods for factorization, which is this method 1. Method number 2 is factorization by inspection. By inspection or by advanced methods is just taking a look at the what is it called, at the factors of minus 10, that such that when we multiply them, they give us minus 10. Those two factors we can have minus 2 times 5, or which is 5 minus 5 times 2. But this is a pair, here is a pair. So to use this one, in this case, we're saying which pair, such that when we remove multiplication, we can get and put addition here, it can give us minus 3. It is this pair here. So in other words, we're saying solving by factorization by inspection is going to give us x minus 5 and x plus 2. So we have factorized. So in other words, we are saying when we make this to be equal to 0, it means literally x is equal to positive 5 or negative 2. We now have x-intercepts. So this is how we basically find x-intercepts. Either you factorize by inspection or you factorize using quadratic formula. So in this case, the graphical way of drawing this is that we can have this, and we have a positive 5 value of x and a negative 2 value of x, which means we can draw our graph as negative 2 here, as positive 5 here. So this is a sketch that we can make. X-axis, y-axis, this, we have this. So our values for x-intercepts are found by making y is equal to 0. We've done that. We solve this stage either by quadratic formula or by factorization by inspection. So, okay, this is how we find x-intercepts. So from x-intercepts, let's move on to the next. Property. In this case, the next property that I want us to look at is the property of turning point. Let's see how do we determine turning points. turning points of a parabolic function. So when it comes to turning points now, let us understand some dynamics, because turning point can be found in 2 or 3 different ways. But let's just take a look at this. We said if we have f of x in this format, let's have ax squared plus bx plus c. Then let's have another format whereby we have f of x, which is in this case a, then x plus p squared plus q. This is the conventional format of a parabolic function, but we also have a format that looks like this. This format, we are saying this is a completed square format. So in this case, when you are given something like this, they want you to find turning points. I want you to take note. Let's have an example here. F of x, if we have our same example that we're using, which is x squared minus 3x minus 10. Then let's have a different one here. F of x is equals to, let's have 2, then x plus q, and then plus x plus, let us remove q and put 3, and then here, let us put maybe 7 squared here. So we have 2 formats. These are different examples, so take note of that, they are not the same. This is a different format. When you have this kind of format, how do you find your your turning points here? So turning point for this one, which means you must use a formula which is x, or finding x first. X is found by negative b over 2a. Let us continue. Substitute our b, our a, which means negative first. Our b is negative 3 over 2a. In this case, we are going to have positive 3 over 2. This is how we find x value for the turning point. Now let us find y value of the turning point. Y is given as x, in this case, is we are going to substitute this x into this original to find y value of the turning point. Take note of that. So y is equals to x, which is 3 over 2 squared minus 3 over 2 minus 10. So final answer here, when you press a calculator, is going to give you negative 49 over 4. This is the y value for the turning point. So in other words, we're saying our turning point here is such that 3 over 2 for x, y is negative 49 over 4. Here is our turning point. So when we want to put this on a sketch, it means we make our sketch, we draw our sketch, and on our sketch we have our x values, our x intercepts. The turning point in this case is this one here. Here is our turning point. X value 3 over 2. Here's our turning point. Y value negative 49 over 4. So we have a turning point here. But if you are given this format here, which means for you to find the turning point, this is very easy. You are going to have the value of x, in this case, just change the sign. If there's a positive, it's going to be minus 3 is to, we have 7. This becomes our turning point. Just take note of this x value and your y value in this case. So you have a turning point which can be given as minus 3 is to 7. So turning point from this format, turning point from this format here. So thank you so much for watching. We'll see you again in some other videos. Thank you.